All right. Hello and welcome everyone to this week's Skyna review meeting. We're focusing on the v1.132 release, and we have a tight schedule actually today, so a lot of items on the agenda. And we'll start right ahead with Sebastian presenting the custom server configuration for the node-local-dns. So Sebastian, stage is yours.
Hi, as Tim said, I will show you the change and support server block imports for local DNS, and let's directly dive in. So first of all, we can take a look at the core DNS custom config map. How in general for core DNS the server block looks like when you specify it. So there we have a name, the server block, and then in the demo server block, which I've designed, what I do, I change the load time for the cache. I rewrite the demo server name to the Kubernetes default service and forward it then to the kubedns server to show you in the end how it works. So what was the problem? So when we take a look at the node-local-dns config map, where we want to support it, then we see that it basically bounds to port 53, and the core DNS server itself is running on 80.53. So what we need to do, or what we have done, we added a sidecar to the node-local-dns server, which basically watches a directory as a core DNS config map gets mounted, and then we pass that config map and change support. We also have to add a bind statement for node-local-dns. For Cilium, it's a wildcard host address, and for node-local-dns or with Calico, it's a link local address which is used by node-local-dns and also the cluster or IP or kubedns service. To take a look what the config looks, which the sidecar renders. Let's take a small look. Scrap DNS. So we see that here's a core DNS. The core DNS config adapter is running under this process, so we can take a look at the generated file. Root etc general. Okay, and if we compare it now, so basically it has changed support to port 53, added the bind statement, and then set the configuration. To show you that it now works with node-local-dns, I've started a Ubuntu pod, installed the DNS utils, and now we can do a name server resolution on the demo server. And what we get now is the IP of the Kubernetes default service. We can check it, which can just get the service and see that it's the correct one. And yeah, that is basically about the change. What also has changed before with core DNS, if you specify a port 53, so we haven't supported that because core DNS was basically listening only on 8053, and now we also support that block. So the sidecar does a little bit more, but overall we have now also supported the server blocks which work for core DNS now. Okay, that's it about the change. Any questions? Then I can give back to you, Tim.
Yeah, thanks, Sebastian. Thanks for the demo. As there are no questions, we can continue with Benedict, who will present the disaster recovery guide.
Yeah, nice being here. Okay, so What this disaster recovery merge request does is, well, it actually tests the disaster recovery of the Gardener cluster for the first time. Back when we started in like a year ago, we like found a backup utility of the garden cluster, and we were like, yeah, we have a backup, but how do we restore that backup? So after a bit of tinkering and some finding out and like a much and healthy discussion with Hendrik, we found out that there's like more needed than meets the eye. First of all, there's backups
Henrik,
needed.
sorry to interrupt you. Are you sharing something? Because
No, I
at least
can't.
I don't see a screen.
It just like had me permission to share, otherwise I can't.
Not getting any permission request. Let me double check that. So, but you wanted to share something, right?
I mean, I could, but there it is. So I need to share.
It should be a presenter.
Share this. Perfect. So, it's a docs merge request. So I'm actually sharing the docs in the commit, so it's readable. This merge request is from us and Hendrik, and it's about the disaster recovery. It's about restoring a garden cluster to a new runtime cluster. Back when we started in like half a year ago, or like even more, a year, we found a backup, and we didn't know how to restore. So we were a bit like we were tinkering around by ourselves, and after a while we were like, yeah, no, like this ain't working. Then we got Hendrik on board, and after some tinkering, we found out that there's a lot more than meets the eye to actually restore a garden runtime cluster. The most important thing is that you needed to have backups. Like if you hadn't backups of some major encryption configs, then like your backup is nil because you can't restore it because like without the crypto information, like you can't read the restored information. After we figured that part out, the next part is like the order of things to happen. Mostly it's about like scaling down all the automation, especially the operator, but also the API server. And afterwards, well, you make a copy of the backup because you only have that one, and if it's gone, then it's gone, and it will be overwritten in the moment you're redeploying. So have a backup of your backup, so your backup doesn't get corrupted. With your runtime cluster, CIDRs, the important part is to then get the garden operator backup to delete the webhooks, because those will prevent you from actually applying your backup. Then you need to have your secrets back in for your CAs, for encryption. I won't go into details. Like if you're interested, like please test your restore yourself. It's like a very important mechanism. A backup is meaningless if you can't restore it. Afterwards, well, it's the usual thing. You go back to applying your garden resource, then it will host your cluster. Then there's something which is mostly relevant for the SAP itself, or like I think they are using it, but not too sure. There's this phase prepared thing, which will need to be manually patched to, well, like I didn't really get why it is. I think that like the moment the cluster is hosted, like the key rollover is done the first time to get rid of the bootstrap issue, but I'm not too sure how it works. And afterwards, well, forgot what this step does. And then you're going back up to the like full-blown etcd cluster, like you're restoring in a single etcd cluster, because also in this moment it's easier if you only have a single node. And well, that's mostly it. The next step is to, well, get a force restore operation in place. We thankfully got some help, or will get some help in the coming hackathon, where we're trying to think about like adding a force restore annotation to shoots. So, well, we also get the shoots running, because like having a Gardener backup running is nice, but if it doesn't know it shoots, well, it's kind of pointless in like real world environments. That's it. Thank you.
Thank you, Benedict, and also thanks for bringing some enhancements to this area. Are there any questions to Benedict? All right, no questions. Then next up is Tobias.
Oh, hey everybody. So today I don't have such a huge topic to present. It's rather a small one. So it's about this issue that actually turned 1 year today. And it was a request to add the possibility to add quotas for project resources. So we can, for example, limit the total amount of projects that a Gardener landscape can host. And after implementing it, this is now a feature in the Gardener admission controller. So it is now possible, in addition of specifying a size limit, you can also specify a count limit for cluster scope resources. If you have namespace resources and you want to add quotas for that, you can just use the Kubernetes native functionality of that. And I can show you a quick demo. So I have a local setup where I configured that I, for example, want to only have maximum of 3 projects in my landscape, but this actually works for every kind of cluster scope resource. But I mean, for projects, it makes the most sense in the Gardener use case. And if I now get all projects, I now have 2. And if I add 1, I create 1, I have some temporary ones, this works. But if I want to add a 4th one, the resource gets, the request gets denied because only 3 are maximum allowed. And I think that's already it. If there are any questions, feel free to share. If not, I can give you back a few minutes.
Very efficient and clear presentation. Thank you very much. Any questions? Last chance. All right, no questions. Thanks again. And next is Florian.
Yes, hi, thank you. I will share my screen and talk about what I have to present. But first, for a small live demo, I have to match this depender port pull request very first. Okay, after that is done and that triggers a pipeline, I can talk about the topic I want to discuss, which is continuous integration, continuous delivery for applications running on Gardener. So I am a developer in the Garden Linux team, and I am working as part of that on this application called GLVD, the Garden Linux Vulnerability Database. And naturally, that is deployed to a Gardener cluster. So we can have a look at the running pods here. It's a relatively simple application in terms of Kubernetes deployments, I would say. So it has this deployment, that is the backend, where I just merged the pull request. It has a database, that's a stateful set, and it has a few jobs, cron job, and jobs that are also triggered when certain action is happening, like, for example, when we're releasing a new version of Garden Linux. And so the topic I want to talk about now is I was as a beginner in like operating applications. I was then wondering, okay, I now have this application. By the way, it's open source also, as you can see on github.com. And so I was working on the application, on the backend, on the database, and manually updating the deployments. And it was a bit annoying. And I wanted to get this automated, and was talking to various colleagues about how this could be done. And I wanted to show the setup that I currently have. And yeah, so we will be seeing when this pipeline is through that then this pod will be replaced, and we will have a pod that was then newer, and the application will be updated. Quick word again about GAVD, the application that I'm building. What is it actually? It's a vulnerability database that is work in progress. If you know the Debian security tracker, then you roughly know what the idea is. So it should give you information on certain vulnerabilities that exist, and if a certain version of Kali Linux is affected by that. And also one of the things that we do is, and that also brings then the additional value is that we do look at certain vulnerabilities and look if they are if we're actually vulnerable to them, if they are false positives, and this is what we call the triage process. And GAVD also gives you the option to view those triages, which is pretty nice. So this whole setup is still work in progress. Just sharing that to motivate the problem. And yeah, also I have to show documentation, because after I was talking to colleagues and got really good support in setting that up, I then thought, hey, maybe this would be interesting documentation, because maybe this case is also interesting for people. There was no existing guide for how to do this, and I thought this would maybe be pretty cool. This has a few limitations. So this, I only now tested it in the setup. I have the application on github.com on GitHub Runner, so I didn't try it with GitHub Enterprise, and I also didn't try it with other CI systems or code forgers. I think it should still be applicable. So if any one of you has different setup, then feel free to try it out and also provide feedback on what needs to be changed in the guide. And yeah, so this is using structured authentication, which is a relatively new feature in Kubernetes that makes the whole setup a bit easier. I was using OpenID Connect before, but there I then still needed to have a prepared kubeconfig as a secret in the repository. And now I don't need that, which is pretty neat. Yeah, let's check how far the pipeline is. One thing that I was a bit one thing I had to wrap my head around, and I also heard with colleagues who tried to set up a similar thing that got a bit confusing, is that you do have to deal with two different kube configs to set this up, because you need to configure. You need to have a config map in the garden cluster and configure the chute to use this config map. And this is something that I done here before. I've done for the first time now in this setup. So to actually get the kube config for the garden cluster and then get confused about why I'm not able to see anything. And all this. So, I mean, I think it's not hard, but it's definitely a pitfall that one needs to be aware of. And I also try to make this very clear and understandable here in the documentation, but I'm also here looking for feedback. So if you think that something can be improved here, then feel free to reach out. Yeah, I also, I mean, one limit that I have here in my setup, I mean, that's not a principal limit. I only want to have deployments here on the main branch. So I do have a few repositories, and when a pull request is opened, then I don't need to deploy them anywhere, which is also why I restricted everything to the main branch directly. So you can also see that here in the username that is then being created, that it has refs head main. I think it would also be relatively easy to have a deployment that to have a setup that deploys pull requests. But in my case, this is just not needed. I mean, maybe it would be nice to deploy them to different namespaces or something like that. But yeah, that's simplification that I think then is the right in my setup. But yeah, also there, if you have more complex needs, then also feel free to provide feedback on this documentation. Yeah, because it's open source, you can also see the workflows. So you can see this is the commit where I made a change to structured authentication. So that's the setup that I'm talking about now. I had this other setup with OpenID Connect and the kubeconfig for around 1 year that was running, and it was running perfectly and flawless, but just switched to structured authentication because it's newer and it allows me to get rid of this kubeconfig secret. So yeah, that's pretty cool in my opinion. Also, shout out to the CC-utils repository and the Gartner team that is working on that. They have this really useful Kubernetes auth GitHub actions. So once you figure out what those parameters need to be, then it's really simple to set up, and it creates you a kubeconfig that you can use. And yeah, what then my pipeline does is kubecontrol set image to update the image of the deployment. And yeah, so this is going to happen. I don't know if I'm already over time. So this pipeline takes between 8 and 11 minutes. So this is why I merged it as the very first thing, because I did want to show how it's running through. If we're running over time, then maybe, oh no, now we're here, authenticating to the cluster, deploying the image, it's updated. And we should now be seeing that the new one is container creating, the old one is still running, and that it's then updated. And yeah, I mean, of course, this is now a setup where then bugs that might be introduced are directly reflected in the cluster. But I mean, yeah, this is exactly what I want here because it's continuous deployment. And yeah, now you can see we have the new pod that was created 24 seconds ago, and the old one is gone. Yeah, I think this is all I wanted to share. I wanted to invite you to contribute to the documentations. If you have use cases, if you have questions, then I think my experience was really good contributing to the documentation. And yeah, just wanted to share this small thing. Thank you.
All right. Thanks, Florian. Thanks for the hands-on and the documentation. Very nice. Does someone have a question already? Okay. Otherwise, please feel free to reach out later. Then we'll continue with the agenda, and next up is Axel.
Yeah. So yeah, this change is about migration back from dual stack to single stack. When we implemented the migration from a single stack IPv4 cluster to dual stack, we just didn't think about the migration back, since we thought first you can't remove all changes in the infrastructure, and then we thought nobody will ever need it. And we didn't want to do the implementation. But yeah, it turned out some people got stuck during the migration. There was one case where in a region in AWS, there were no instances available that supported the IPv6 prefix delegation. There could be other reasons why people want to migrate back. Maybe their workload is not behaving as expected, or yeah, we should see it more as an emergency exit. So just provide the way back. This change doesn't consist only in changes in the Gartner repo. We also needed to change some things in the provider extensions for GCP and AWS, and we also had to change, had a little change in the machine controller manager for GCP. So maybe just start with the added documentation for this back migration process. Yeah, important consideration. Not everything is migrated back to single stack. Still, you have infrastructure resources that have IPv6 addresses. And for GCP even, we keep the alias IP as the pod range assignment for on the nodes. So we wanted to revert that again. But besides that, after the migration, you should have an IPv4 cluster. From the Kubernetes point of view, that just looks like an IPv4 cluster. You start the migration with just removing the IPv6 entry from the IP families. That will immediately trigger a reconciliation and configure the control plane components to IPv4 single stack. We also set in this step a dual stack migration constraint to indicate that the migration is ongoing. As a second step, we would recommend, or it should be done, a node rollout. After the control plane is reconfigured, all running pods in the chute will stay on IPv6, still have an IPv6 address, and the nodes will have an IPv6 pod pseudo range in the node resource. So a node rollout will remove all the nodes. New nodes will get IPv4, only IPv4 pod pseudo ranges, and all restarted pods will only have IPv4 addresses. And after that, the cluster is just in a single stack IPv4 mode again. Yeah, I set up 2 clusters that I migrated back. Here we see the garden, and if we look at the first cluster, I removed the IPv6 from the IP families. There's one reconciliation has already run. We have the dual stack migration constraint, and we see in the networking status that we have the IPv6 ranges here. If we look at this cluster, maybe first at the services, just look at the v1.1.32 service, it already has only an IPv4 cluster IP, since the API servers restarted only with IPv4 configuration, and all the services are updated or redeployed with IPv4 addresses. But if we look at the pods, then we still have IPv6 addresses. Pod IP is still IPv6, and if we look at a node, then we still have the IPv6 pod pseudo range. I have now an additional chute where I already wrote the nodes. In this case, yeah, only IPv4 as IP family, constraint, only 2 constraints, and the migration constraint is gone. We have still this IPv6 addresses in the networking status that will stay there. We will not remove it. It's something, yeah, it's a property of the infrastructure, and something where we can see this stack was dual stack and is single stack now. In this case, migration is finished. Service was already before on single stack. Pods now only have IPv4 addresses, and from the node, the pod pseudo range just has this IPv4 entry. Yeah, I think that's already it. We can migrate back now. I would see it as an emergency exit. It should be there, but hopefully nobody will ever need it. Any questions?
Thank you, Axel. So I have one question. The migration back is also possible while you're in the migrating phase to dual stack. Is that correct?
Yeah, that's correct. I didn't show that, but I have even this diagram. It was a little bit too complex. I thought you have all the migration states. You start with IPv4 only, you migrate to IPv6. Here you have just the infrastructure. You can migrate back directly. In this case, node rollout is needed. Here you have the control plane. You can migrate back. Then you need the rollout, and in every state of the migration, it's possible to get back. So it's not needed that it is completed. Obviously, that would not be what we want if you are stuck during the migration.
Okay, very nice. Thank you very much. Okay. Guess there are no more questions. Then Oliver will follow up with an update to the IstioTLSTermination.
Yes, I'm here. Just give me a second. Yeah, okay. I should be visible. My screen should be visible. So
Yes, it is.
I'd like to present you this PR, and I might also sneak in another PR, which is about the same topic. Yeah, we are testing this IstioTLSTermination or layer 7 load balancing in a broader audience now. And yeah, when you start using a feature, you discover issues you didn't see before. And so, yeah, was this issue here. We had a cluster, some clusters with strange behavior where like nodes, the node status were flipping, and we checked the logs and saw the put requests which updated the leases, they failed often. And also watches from kubelet have been cancelled, so which made the whole process unstable. And we did a bit of a research and came across this feature gate here, the unauthenticated HTTP2 DOS mitigation feature gate, which is enabled now by default. It was introduced to mitigate this HTTP2 rapid reset DOS vulnerability. And basically it's doing one thing, it's closing connections, and it's closing connections in two cases. First case is when there's an anonymous request, and second case is when there's an unauthenticated request. And yeah, when you now look at this layer 7 load balancing setup, we have a flow here from the shoot cluster here through the Istio Ingress gateway pod to a Kube API server replica. And in case of layer 7 load balancing, we have one HTTP connection here and a second one here from Istio to Kube API server. And in case Kube API server is closing the connection, it's closing this connection and not the connection to the client. And yeah, when you have a load balancing setup with HTTP2, there could be multiple streams from multiple clients using or sharing one connection, and all these streams would be closed, which is obviously not good. This is also mentioned in the pull request where this feature was implemented. When you check here, that's basically what I said. Okay. So yeah, and as we have Envoy or Istio Envoy, there's a different mitigation for this HTTP2 vulnerability anyway. It basically counts the number of reset streams, and yeah, it's not important how it works exactly, but there is a mitigation for it. So our idea was, we set the feature gate to false every time we use this layer 7 load balancing. And yeah, this is implemented by the PR. And when we did it, we rolled it out and said, we fixed all our issues and set the cluster back to layer 7 load balancing. And after 5 minutes, we had the same issue again. So it was obviously not the root cause of it. And this brings me to the sneak in PR, which is also in the release, but as the first hotfix. Now we had the opportunity to do a kind of live debugging session, and we kind of found out that the number of connections between the Envoy pod and the Kube API server pod went through the roof. So in some cases, we have a connection limit configured in Garden of 5,000 connections per Istio Ingress gateway and Kube API server, and this was reached. This was reached, and so the queue for outstanding requests, it's basically unlimited. It's like 4 billion requests. So those requests really timed out, and after a while, we found out that the configuration was not 100% correct. And there's like one sentence in the Istio Ingress, in the Istio config, which tells you, Istio Ingress, when it acts as a gateway, it uses HTTP 1.1 by default. And that was the case, for our layer 7 load balancing too. So we had to kind of a connection downgrade. So when we look back here to this diagram, here this connection from the client to the Istio Ingress was still HTTP 2. But this connection here between Istio Ingress and Kube API server was HTTP 1.1. And then you have a single connection per request. And of course, they can be reused. But if there are many requests, we could hit the limit. And that happens. So we introduced here this PR, which is configuring the destination rule and setting a use client protocol. And basically when now a client starts a HTTP 2 connection, it's routed to the Kube API server as an HTTP 2 connection too. That makes a big difference in regards of connections. So we counted the connections before. We had like 5,000 connections between one instance of Istio Ingress and the Kube API server backends. And after we enabled this feature, there were like four connections left. So 4,996 connections less. After we implemented this, now this pull request, which we did before, is relevant. Before the fix, it was not relevant because the backend connection didn't use HTTP 2. But now all the things I explained here before, they are applicable once you use the patched version, and with the first sub-6 release. Any questions? By the way, it's very hard to reproduce this, so I was not able to set up a demo. So it's you need lots of connections, and there are multiple connections between here and there, and it's very difficult.
Yes, although I have one question about the connection limit now that we use HTTP 2. Do we need to revise these 5,000 connections? Because you just mentioned you just needed 4 for the same amount of traffic now.
Yeah.
Yeah.
So I put up I have an action item for myself to check this connection limit. Because I think this connection limit is not doing what we expect it to do. It is limiting the connections between Istio Ingress and Kube API server, and depending on the setup, this could result in different things. So, for example, when you have a very lazy Kube API server, which has just, let's say, one replica, no HA, and so it has just one replica, but it's running on a very busy seed, and the seed has like 20 replicas of Istio Ingress. Then you have like 20 times 5,000, 100,000 connections pointing to a single Kube API server instance, because this limit is per Istio Ingress pod, Istio Ingress gateway pod. And the other way around, when you have a very, very busy Kube API server with like 6 Kube API server instances, but only one Istio Ingress instance, then you would have only 5,000 connections for all the 6 Kube API server instances in combination. Yeah, so I didn't have a final solution for this, but I have it as a kind of an action item to think about this limit. There are also other limits, like the length of the request queue and so on. We can play around, but it's definitely something we should look at.
Okay, thanks, Oliver. Just one addition. Do you want to say a few words about the upstream issue you needed to open for Kubernetes?
Yeah. Good. Yeah, good remark. Thank you. I raised an issue at Kubernetes, and which is basically telling or asking whether this feature gate should be converted into a configuration option. To prevent that a future Kubernetes version might break our setup again in case it's promoted to GA, for example. Yeah, I'll follow up on this issue.
Okay. Then thank you again. The last topic in the agenda is the on-demand worker pool rollout presented by Rado.
Hello, hopefully you can hear me.
Yes.
So the showcase should be really quick and simple. I'll just show you what happens. So if you have, for example, a shoot, the shoot has some worker pool, in this case named local. This worker pool has one machine. You can basically now annotate the shoot with a new operation called rollout workers. You give the name of the worker pool, and when you do that, and then you check the machines, you can see that a new machine has been started, and the old one will eventually enter a terminating status, and this way you have successfully basically forced a new rollout of the specified worker pool. That's everything that basically happens. What I can say is that this topic actually is from the hackathon in June. So it's been in the oven cooking for basically 6 months. Not because it's very complicated, but mostly because actually the way we started doing this was in a similar way that the worker rotate rollout operation works. We found out after that actually that the reason we wanted to do it like that operation, but we found out that that operation, the way it does it, is more complicated than the way we need to do it. And this PR was closed, and a new PR was made that actually implements this in a much simpler way. What basically happens is you add the annotation to the shoot, and then the gardenlet actually adds a new annotation to the machine deployment, and that annotation basically makes the MCA force a new rollout of the machine. There are actually two things that I can mention. One is that instead of giving a name, you can also give basically globbing is supported using the star. This forces all worker pools to manually be rolled out. And another thing that can be mentioned is that actually this does not work when you have in-place updates enabled. The reason for that is basically that in-place updates, they try to basically circumvent the need for the machines to be recreated. That would mean in-place updating. And due to its nature, it conflicts with what this tries to do. And if you try it when you have in-place updates enabled, it just won't work. And that's about it. That's everything that can be said about the topic.
Thank you, Rado. Are there any questions for the last topic? Okay, no questions. So this was already the last topic. Just a short reminder, the next review meeting will happen in 2 weeks on December 3rd. It will already be about the hackathon wrap-up. So the hackathon will take place next week. For everyone who will join there, have a lot of fun. Happy hacking. And yeah, thanks to all the presenters today. Thanks for joining the community meeting. And see you in 2 weeks. Have a good time. Bye-bye.
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 See you.
Bye.
See you. Bye.